Hello guys, welcome back to Programming Programmer. So today we are going to solve the problem count the triplets. This is going to be an optimized version of the solution that I described in my previous video. If you have not seen that video, then I would recommend seeing that video. So the problem is we are given an array of distinct integers. The task is to count all the triplets such that the sum of two elements is equal to the third element. So don't worry, I will link this question in the description box. So let's see what the problem is. So the problem is saying us that we are given an array with n integers and we need to count all the triplets such that the condition x plus y is equal to z holds. Here x, y and z are the elements in my array. So let's see how we are going to solve this problem. So before solving this problem we need to do some pre-processing that will hugely help to optimize our solution. So for pre-processing, let us assume that we are having our array as element as 1, then 3, then 5, then 0, then again 0, then 1. So this will be our array, this will be our given array ARR. And now what we are going to do is we are going to find the maximum element in this array. So clearly the maximum element in this array is 5. We can find this in order and operation, by traversing this array once. Now what we are going to do is we are going to make another array, and let's say that we name that array exist. This is going to be a boolean type array, and in this array we are going to give it a size of maximum element plus 1. So this will be having a size of 6 in this case. So 0, 1, 2, 3, 4, 5. Okay, so this will be our array. This is of size 6. So initially what we are going to do is we are going to say false in all the places, and now what we will do is we will check whether we will traverse this array once again, and we will check that 0 exists. If 0 exists, then we are going to save true here. If 1 exists, then we are going to again save true here. If 2 exists, which does not exist in our main array, then we are going to just leave it as false. Now if 3 exists, then we are going to save true here. If 4 exists, then we are going to save true, but here 4 does not exist, so we are going to save false. If 5 exists, then we are going to save true. So this is how we will make our exist array. Now this is all about the pre-processing. Now we will jump to the main code. So now what we are going to do is, with the help of this, we will first of all maintain a count variable, and initially we will give it a value of 0. This will save our answer. This is going to save what will be the count of all the triplets in our array. So now what we will do is we will run a for loop, and we will go for I equal to 0, I is less than n, then I plus plus. This is how what our for loop will look like. And then again in this we are going to run a nested for loop for j equal to I plus 1, j is less than n, j plus plus. So we are running our outer loop from 0 to n. Then we are going to run our inner loop, that is a nested for loop, from I plus 1 till n. Then what we are going to do is we are going to check if a RR of I plus a RR of j is less than equal to whether ARR of I plus ARR of j is this less than equal to maximum element. We computed the maximum element of our array. Then we are going to check this condition. If this condition holds, then what we are going to do is we are going to check if exist ARR of I plus ARR of J. If it exists, then what we are going to do is we are just going to increment the count variable. So this is how we will count the triplets from our array, and then we are just going to return the count variable or print the count variable. So what is happening here, how it is solving our problem? So what we are doing here is we are running a loop. We are going for each value of I, and then we are going for j from I plus 1 to n. Then we are doing is we are checking this condition. We are checking this condition because in the next condition what we are going to do is we are going to check if this exists or not. Okay, so if we will not check this condition, we will not check whether it is less than equal to maximum element, then we are going to get segmentation fault. Okay, so first we are going to check this, then we are going to check if this exists or not. Okay, so fundamentally what is happening is we are just checking if x plus y is equal to x plus y. Okay, if x plus y is equal to x plus y, that is all we are checking here. So we found x, then again we found y, and our condition was this that we need to check x plus y is equal to z. So that is what we are doing here. We are checking if for this array, if this x and this y it exists in existing array, like in this array. If it exists, if true is marked at this place, then we are just going to increment the count variable. So we will do this, and this will solve our problem. So this problem was a more optimized version of the previous solution that I had discussed, and the reason, like, this is also an order n square solution. So what is the difference between those two? So the difference is, like, it is having its n as the maximum element in the array. Let's say that maximum element is order of 10 raised to power 9, but the number of elements in our array is order of 10 raised to power 3. Then in that case we are going to get a segmentation, we are going to get TLE, because that is order n square approach, and n goes to 10 raised to power 9. But in this case, as we are having only 10 raised to power 3 elements, then we are not going to get segmentation fault. So this is the fundamental difference between the solutions of this problem. And again, the space complexity is order of n in this approach. So time complexity is order of n square, and space complexity is order of n. Thank you for watching. If you like my content, then do like, subscribe and share this video.